Hello everyone and welcome to our presentation. We are Robomex, group number 8. Me, Salvador Peña Jimenez, and my teammates Maria Fernanda Amaya and Joel Sanchez are going to be presenting these slides.
I'm Maria Fernanda Maya. I am the project manager, and I was responsible for the robot part of the project. I have previous experience in working with industrial robots, so I was able to help the team to fulfill that area of the project.
I'm Salvador Peña Jimenez. I'm the technical manager. I was responsible for the electrical part of the project. I was focused on getting the circuits to work for the vacuum and the industrial PC and the lights. I also worked on the setup for the lights and the cameras for the segmented toad and the robot.
I'm Joel Sanchez, and I'm the research specialist, and I was responsible for most of the software implementations for the project, including the user interfaces and the database. And human beings have been forced to create different contactless systems for customers all over the world. We noticed that prescription pickup lines at pharmacies was not the most pleasant experience, considering the wait times while being surrounded by possible contagious diseases. So we found a need to decrease these lines and avoid human interaction as much as possible.
So what is the automated pharmacy dispenser? Our goals are to speed up lines in pharmacies to pick up medical prescriptions, reduce human interaction, and provide contactless service to customers. We're doing this by integrating an industrial robotic arm and a user interface for the employee and the customer to automate the process of picking up prescriptions at a pharmacy.
This is how the setup of the whole system looks like. We have the UR10 E-Series in the middle as a robotic arm of choice. This robot is a collaborative arm which facilitates the placement of the system since it can be around humans without the big risk of getting hit hard by it. This robot will stop the instant it hits something, unlike other industrial robots that just keep running. Then we have the lights and camera setup arch with both items in place. The lights and cameras overlooking the toad on top of the table to keep the point cloud readings constant. On the left, we can see the IPC where most of the operations happen. It has PIC1 installed, the user interface and database, and the server to control the robot as a client via TCP, which is the transmission control protocol. And for the robot to actually pick up objects, we have the air pressure coming out of the valve and in the right, going into a vacuum that is on the floor that creates the suction for the gripper, as you can see at the end of the R tool of the robot. So how it works, we have two sides of the interface. We have the employee and the customer. Once the employee completes the prescription, he or she will input the customer's first and last name, the date of birth, and assign a slot for the prescriptions. This information is then sent and saved to a database. The customer will then go into the pharmacy and check in with their information, which is the first name and last name and the date of birth, to confirm their identity. This information will be compared with what is saved in the database. Here we have the toad, we have the robot behind the toad, and we have 8 regions for the toad. There's 0 to 7. We have 0 to 3 for one camera and 4 to 7 for the second camera.
The initial design idea was to build an automated checkout lane using a robotic arm. Objects would be grabbed, scanned, and then placed in a bagging area. And our final design idea is the same concept, but only apply it in a different way. The automated pharmacy dispenser picks and places medical prescriptions to deliver to the customer for a checkout.
Software block diagram. Our diagram is broken off into 3 different pieces. The employee user interface starts by choosing an open slot. They scan the prescription, they save assigned slot, and they save to the database. Then the customer will come and input their name and date of birth to confirm the identity. The system will then compare the information with the existing data in the database, and it will retrieve that data and get the slot location. The third part of this diagram is the payment process and the dispensing. The system will first ask for the payment, and then the vision system of the robot will identify a pick position of the slot and pick up the prescription. It will then place the prescription onto a dispenser, and the system will determine whether or not the payment has been completed. And if it has been, it will release the items and delete that assigned slot from the database. However, the payment process of this diagram was not implemented into the final design due to lack of time. This is a demonstration of our project. The pharmacist places the prescription into a segmented tote and then inputs the customer's information by first name, last name, date of birth, and the slot number in which they're putting it in. They then hit submit and it will send to the database. Here we are demonstrating 3 examples of assigning data to the database. Here we're showing the database to show that the data inputted was saved into the database based off those informations. As you can see, the list of customers is updating as we input the information in. So here the customer will walk into the pharmacy and pick up the prescription. The customer will input their first name, last name, and their date of birth to confirm their identity. They will then hit submit, and the data is sent to the robot, and the robot will determine what slot their prescription is in, and will pick it up. This one was in slot 0, and it picked it up from slot 0 and dispensed it. The second customer is coming in, and they're inputting their information, and they hit submit, and the robot will dispense from that slot, which is slot number 6. And then the last customer will come in and also input their information, and it's dispensing from slot 1.
Any questions or feedback?